Hello, this is the third video of the first vector series for OCR AS Core Pure Further Mathematics, and we will see how to find the angle between two vectors. You will remember from the previous video the result that A dot B equaled magnitude of A times the magnitude of B cos theta. Rearrange this scalar product formula to find angles. We get that cos theta therefore equals the scalar product of A and B divided by the magnitude of A times the magnitude of B. In this example here then, cos theta, where theta is this angle between A and B, will equal A dot B, or 50.73, divided by the magnitude of A, or 5 squared, and I will put in the 0 squared just so you can see I haven't completely forgotten it, plus 7 squared plus 3 squared. So this is 5 times 7 is 35, plus 0 times 3 is just 0, divided by the square root of 5 squared, which is simply 5, times the square root of 49 plus 9, in other words, the square root of 58. If you put this into your calculator in inverse cos, you will find that theta is approximately 23 degrees to the nearest degree. The same process may be used in 3 dimensions. So we have again rearranged the scalar product formula to find the angles in terms of cos theta equals to, in this case, P dot Q over the magnitude of P times the magnitude of Q. So theta, being the angle between P and Q, will equal cos to the minus 1 of 2 minus 4, 3, 2, minus 2, 1, 3, over the magnitude of P, which will be 2 squared plus minus 4 squared plus 3 squared, times the magnitude of Q, minus 2 squared plus 1 squared plus 3 squared. Again, putting this into your calculator, that turns out to be approximately 87 degrees. You may wish to pause the video here and check the working for yourselves. So in what circumstances would the scalar product give you 0? Well, I think you can understand that having rearranged that formula, that would indicate that cos theta equals 0, which happens when theta equals 90 degrees or 270 degrees. If you think about the cos curve, you can see that those are the two situations in which that happens. So in other words, it'll either be that theta is 90 degrees there, or you have a situation where B is in that direction there, and you've got your 270 degrees going all the way around. In either case, A and B are perpendicular vectors. Let's have a look at this question here. The vector A is given by 2 minus 1 minus 3, and we want to decide which vector is not perpendicular to A. If it was perpendicular to A, we would need A dot b to be equal to 0. So let's check the scalar products. With the first one, we would have that 2 times 1 gives us 2, plus minus 1 times minus 1 gives us plus 1, and minus 3 times 1 would equal 3. That does give us 0, so that first vector must be perpendicular. Looking at the second one, we would have 3 2s are 6, 0 times minus 1, and 2 times minus 3 would give us minus 6, again 0. So the second vector is perpendicular. In the third one, 5 2s are 10, plus 1, minus 1 times minus 1, and then plus 3 times minus 3, so that would be minus 9, and that is not equal to 0. In fact, that would be 2, so this vector is not perpendicular. Checking the last one, 2 2s are 4, and plus 1 times minus 1, and then 1 times minus 3 equals 0, so that fourth vector is perpendicular. So the vector which is not perpendicular is simply the 1, 5, minus 1, 3. Here is another example where we would use this information. This is the 2D vectors A, minus 2, 3, and B, 1k. We wish to find k such that A and B are parallel. You'll remember then that we need the direction vectors of those vectors to be multiples of each other. So in other words, if we compare minus 2 and 3, and we want that to be some multiple of 1 and k, then an n must be minus 2, which would mean that k equals 3 divided by minus 2, or minus 3 over 2 to be parallel. In the second case, where we want A and B to be perpendicular, we know that we need the dot product to be 0. So in this instance, we have that minus 2 times 3 dot with 1k must equal 0. So that's minus 2 plus 3k equals 0. And k is therefore 2/3. In this third example, points A, B and C have coordinates 2, 3, minus 2, 3, 1, minus 1, and 10, 5, 0 respectively. We need to show that angle ABC is a right angle. In this case, we are trying to show that AB dot product with BC equals 0. So AB being perpendicular, and we might want, some people may wish to sort of have a hat over ABC. In other words, it's that angle B that we're interested in. Let me just draw a quick sketch. So if we have A, B and C, it's this angle here that we're trying to show is a right angle. Let's have a look and see, well, how do we find the vector AB? The vector AB is going to be point B, or the vector to show point B, 3, 1, minus 1. Take away the position vector for A, which will be 1, minus 2, and 1. Similarly, BC will be the 10, 5, 0, so position vector for C. Take away the position vector for B, or in other words 7, 4 and 1. And we now need to look at the scalar product of those two vectors. This comes to being, and again I'll use brackets just to make it clear, which is 7 minus 8 plus 1, which does indeed equal 0. And therefore, as long as we state that we have used the fact that if A dot B equals 0, that indicates that cos theta equals 90 degrees, we would have shown that angle B is a right angle. This is the final video in the first vector series.